Welcome to springlib.
If we want to find all the rational zeros and put it in factor form, you can look at the graphs of them first. So if we look at x cubed minus 4x squared minus 11x plus 30, notice it has three zeros at negative 3, 2, and 5. So the factored form would be p of x equals, if it has a 0 at negative 3, then a factor is x plus 3. If it has a 0 of 2, then x minus 2 is a factor. And if it has a 0 at 5, then x minus 5 is a factor. So now it's in factored form. Next, let's graph x to the 5th minus 4x to the 4th minus 3x cubed plus 22x squared minus 4x minus 24. And we see it has 5 zeros, but one it bounces on or touches and turns. So that means it has multiplicity 2. So going left to right, if negative 2 is a 0, then x plus 2 is a factor. If negative 1 is a 0 going through it, then x plus 1 is a factor. If 2 is a 0 but it touches and turns around, then x minus 2 squared will be in factored form. And then it goes through 3, so x minus 3 is a factor. And you've got your 5. I squared is equal to negative 1. So if we think of I to the 2000 or 1002, if we think of it as I squared to the 501, okay, that would be equivalent. And negative 1 to the 501st power is negative 1 because it's odd. If 2 minus 3i to the negative first is what we have, then that's equivalent to 1 over 2 minus 3i to the first, which then we can rationalize by using its conjugate, which would be 2 plus 3i that we have to multiply both the numerator and denominator. So the numerator would become 2 plus 3i. The denominator would be 2 times 2, which is 4. Then it's plus 6i minus 6i cancels, and then minus 9i squared. I squared is negative 1, so it becomes plus 9, which is 13. So in a plus bi form, that would be 2/13 plus 3/13 I.